In the chemical engineering thermodynamics 1, previously we discussed the various cycles like a Carnot cycle and a refrigeration cycle, then the choice of refrigerant, and then now the next process or the next method is that liquefaction processes. Gas liquefaction has gained wide acceptability in recent years. Liquefaction process make tank of storage, handling and transportation of gas simple samples. Liquefaction processes is the storage, handling and transportation of gas samples. In addition to benefits such as the reduction of storage space and transportation cost achieved by the liquefaction process in general, gas liquefaction is widely used for the separation of gaseous mixtures into their component part. Air liquefaction and separation are used to produce liquid oxygen and nitrogen, widely used in miscible and rocket development and low temperature refrigerations. The development in the space result have leads to manifold increase in the use of liquid helium, liquid hydrogen finds application in nuclear weapons development and rocket uh, pro, pro, propulsion. Okay, so liquidification is the main option. So liquidification શું છે કે gas છે that are converted into the liquid form. Okay, so as for the example is our LPG gas is, so LPG is the gas but compressed it and it can be in the form of liquidification in the liquid. So the gas liquefaction is widely used for the separation of gaseous mixture into their component part. Air liquefaction and separation are used to produce liquid oxygen and nitrogen, widely used in missile and rocket development. Low temperature refrigeration, the development in space research. Okay, these are the three general methods for engineering importance for liquefaction gases. First, vaporizations of liquid vaporizations કરો એટલે શું થઈ જાય, liquidification થઈ ગયું. પછી Joule-Thomson's expansion. So other important method is that Joule-Thomson's expansion. Third is the expansion of gas in engine delivering external work. Okay, so these are there is general three method for engineering importance for liquefaction of gases, that is vaporizations of liquid, Joule-Thomson expansion and expansion in gas in engine delivering external work. So let us see, the first is that vaporizations of liquid. This method can be used to reach liquid air temperatures by employing a series of liquids of different boiling points. The liquid of the lowest boiling points absorbs heat from the systems to be refrigerated and delivery that heat to be the next higher boiling liquid in a condenser boiler combinations finally. The liquid air temperature is employed series of liquid in different boiling point. So the lowest boiling point is absorb heat from the system to be refrigerated and delivers the heat to be next higher boiling liquid in condenser boiler combination. So the fluid of the highest boiling point is condensed by cooling by air or water. So this will be discharging the heat of atmosphere, and this method has been used for the liquefaction of air and natural gas, and the lowest temperature that can be attained by this method is 63 Kelvin, the triple point of nitrogen. સૌથી ઓછું તાપમાન ધરાવતું હોય તો એ છે નાઇટ્રોજન, and this one be happened at the 63 Kelvin. Next is that free expansion, or which is based on the liquidification. So it is Joule-Thomson's expansion. For liquefaction of the gas, in this method, the initial pressure of gas should be raised to such a high value that on the Joule-Thomson's expansion, which is an isenthalpic operation, and the constant enthalpy lies into the two-phase region as shown in figure 5.15. જે ગેસ હોય છે જનરલી આ પ્રોસેસની અંદર એને શું કરવામાં આવે છે કે ઇનિશિયલ પ્રેશર જે છે એને શું કરવામાં આવે છે વધારવામાં આવે છે, અને તે વેલ્યુ એક હાઈ વેલ્યુ સુધી લઈ જવામાં આવે છે by the experiment of Joule's expansion. So which is isenthalpic operation. So here is the graph of TS, which is TS diagram of simple Joule-Thomson's liquefaction. Temperature versus entropy. For liquefaction, for example, gas at initial state such as the one represented at point 1 in this figure, gas છે એ એની ઇનિશિયલ પોઝિશન્સ પર એ પર છે, and it is not can be liquefied, બરાબર, અત્યારે એ liquefied નથી. The linear process for the liquefaction works on the principle of Joule-Thomson's expansion. It can be used for liquefaction of gas that cools on Joule-Thomson's expansion, that is for gases that possess a positive Joule-Thomson coefficient, and the Joule-Thomson coefficient and its dependence on the thermodynamic variables are discussed in this sections 6.1.4. Hydrogen and helium being exceptions, even hydrogen and helium have a positive coefficient below 100 Kelvin and 20 Kelvin. So the linear process for liquefaction of air is shown in figure 5.16. The temperature of air at the upstream side of the throttle valve is reduced to sufficiently low value, like 170 Kelvin to 100 bar, so that the constant enthalpy lines cuts into two phase regions, and the cooling of air is achieved by the passing it counter currently to the unliquefied part of the air leaving from the throttle valve. Then fresh air and unliquefied air from the input to be condensed. જે અનલિક્વિફાઈડ એર છે જેને આપણે કન્ડેન્સ નથી કરી એ તે એર અને બીજું ફ્રેશ એર બંનેને ક્યાં લઈ જવામાં આવે છે પુટ ઇન ટુ ધ એટલે કે ઇનપુટ હોય છે કમ્પ્રેશરમાં. એર ઇઝ લિવિંગ ફ્રોમ ધ કમ્પ્રેસર ઇઝ કુલ્ડ બાય એમ્બિયન્ટ એર. એમ્બિયન્ટ એર એટલે એટમોસ્ફિયરિક એર કરતાં વધારે હશે, કમ્પ્રેસ કરી છે ને એટલા માટે. એન્ડ ધેન or it by the cooling water and subsequently by counter current heat exchanger with recycled air. And the throttling valve, a fraction of gas is liquefied by applying first law. It can be shown that the fractions of X can be liquefied air is given by Hc is equal to X of, that is a mole fraction, or is a fraction, into HF plus 1 minus X HF. It is the Linde process for the gas liquefacions. First, A, fresh air it is sent it to the compressor, and then it will be compressed, then it will be sent it to the cooler, and then cooler, after it will be the heat exchanger process is achieved by the change the temperature of the liquid. Then it is send it to the throttle valve, okay, and which is again send it to the separator, which can be liquid and gases will be removed by here. Again, the sum of the gas is not liquefied, then it will be again send it to the heat exchanger, and then again further it will be heated, and then it will be further processes occurs. Okay, so here is the diagram of Linde process for the gas liquefaction. અને જે લાસ્ટમાં એક્ઝામ્પલ આપ્યું, ઇક્વેશન આપ્યું છે એની જગ્યા પર આ રીતે પણ લખી શકાય છે. બંનેમાં એક્સ છે તો એક્સ કોમન લઈ અને આ રીતે એચ સી માઇનસ એચ એ અપોન એચ એફ માઇનસ એચ એ. Okay, so this is the Linde process for the free expansion, and next is that isentropic expansion. So here is the temperature versus entropy graph is given. Which is containing the value of point A, B, C, D, E, F, G. Then isentropic expansion is that the Claude process for the gas liquefaction utilize isentropic expansion of a compressed gas in the throttle valve shown in figure. It will be replaced by an expansion turbine, and the process can be followed on the TS diagram as shown in figure. A to B, it generally up and down momentum of entropy versus temperatures. So the vertical line which represents, that is D, the isentropic expansion DE. D and E is the isentropic expansion, and the fraction of gas liquefied can be determined by the follow: energy balance around the heat exchanger, turbine, and the separator, which is given as that x of Sg is equal to 1 minus x Ha plus x Fa plus Ws, where W is the work delivered by the turbine, and if the turbine operates adiabatically, the shaft work Ws is equal to the decrease in enthalpy of the gas during the expansion. So it will be given by the equation like that, by that Ws is equal to Hd minus He, and the fraction of gas liquefied in isentropic expansion is clearly greater than the free expansion.